Hey guys, today we are learning about equivalent ratios defined through the value of a ratio. So this is lesson 8. Today I will understand the value of the ratio A to B is the quotient A over B as long as B is not 0. So your denominator cannot be a 0. Use the value of a ratio in determining whether two ratios are equivalent. So the value of the ratio gets kind of, now we have a ratio. And ratios are two ordered numbers, right? So we have 1 to 2, and they're in the correct order. That's why they're called ordered numbers. And one tells us that this is how many for one thing to 2 of another thing. So we've learned about equivalent ratios, looking for ratios that are equal to or the same as each other. And so now we are slowly making our way to learning what the value is. Right now we have two random numbers that have been placed together, that been placed together in comparison of each other. Now we want to give a value to them, put them on the number line. So our exercise 1 is telling us to circle any equivalent ratios from the list below. So we have ratio 1 to 2, ratio 5 to 10, ratio 6 to 16, and ratio 12 to 32. So I want you to pause this video right now and see if you can circle the ratios that are equivalent to each other. So you've thought about it, and we have found that 1 to 2 is equivalent to 5 to 10. Okay, why is it equivalent? Because 1 times 5 equals 5, and 2 times 5 equals 10. Remember, whatever I multiply to 1, I also multiply to 2, and that gives me an equivalent ratio. Our other equivalent ratios are 6 to 16 and 12 to 32. Because 6 times 2 equals 12, and 16 times 2 equals 32. So now we're going to find the value of the following ratios. So leave your answer as a fraction, but rewrite the fraction using the largest possible unit. Now, basically what this is asking you to do is to rewrite your ratio as a fraction. Okay, now you're giving value to that ratio. You're placing it somewhere on the number line. Now they're not just two numbers that have been together. You now know we're trying to figure out what their relationship is and what their value is on a number line. So take some time right now. Think about it. Okay, our first ratio, 1 to 2, tells us the value is 1/2. Right, 1 over 2. Here's your first number is your numerator, or your second number is your denominator. We said that 1 to 2 and 5 to 10 are equivalent, so the value of this ratio is 1/2 as well. If you write 5 to 10 as a fraction, you would get 5/10, and you would know that 5 goes into 10 2 times. So you simplify that fraction to 1/2. Okay, so pause your video right now to write your answer for the other two ratios. What do you notice about the what do you notice about the value of the equivalent ratios? Okay. Pause your video to write your answer to this question. So when I come around to check your notebooks, I will be looking for the answers to the value of the ratio for these two ratios, and your answer to what do you notice about the value of the equivalent ratios. All right, exercise 2. Here is a theorem, okay, or a theory. If A to B with B not equal to 0 and C to D with D not equal to 0 are equivalent, then they have the same value. A over B equals C over D. Okay, remember your A is your numerator, your b is the denominator, and b cannot be a 0. C to d, c is your numerator, d is your denominator, with d not being 0. This is essentially stating that if two ratios are equivalent, then their values are the same when they have values. So when you've given them numbers, okay, then you are telling us, this tells us that these two ratios are equivalent, and that automatically means that their values are the same. So when you put them on the number line, they would be in the same spot. Can you provide any counterexamples to the theorem above? So work with a partner to see if you can come up with a counterexample to this theorem. I'm going to give you an added challenge. If you come up with an example that you feel makes this theorem false, then write it up on the board and then let's work it out together. So you can find a partner to do this. Our lesson summary. The value of the ratio a to b is the quotient a over b as long as b is not 0. If two ratios are equivalent, then their values are the same when they have values. All right, so if you had paused this video to do the exercise, then you will realize that this is our true statement, that when you have two ratios that are equivalent, then their values will always be the same. There really is no counterexample to this statement. Your next steps. Finish exercise 2 and 3. When you are done and feel ready, get an exit ticket from Mrs. Caldwell. Homework is to finish exercise 2 and 3. If you have any questions, write your name on the board. Until next lesson.